Hey guys, hope these videos are helping. I know I'm kind of doing a bunch of them and you're probably irritated with my voice by now, which, welcome to my life. I'm irritated by it every day. If you want to shout out or tell me any improvements that I can do, definitely let me know. If you guys think there's something bad with the video, I'm always open to suggestions. Anyway though, here comes the next circuit, parallel circuit. So definitely different than a series, and you can tell I gave you the hint right away. There's going to be multiple paths. So if I did want to draw the current, conventional current leaving the positive terminal, this right here is a major place. So this is what is called the junction, which you've heard me kind of say that in the other videos. And this is where the current can split and go down, let's say, resistor 1's path, and also go down resistor 2's path. So that's the major difference. The rules still apply as long as you know the rules really well. I'm not going to do so much with the rules and the number and Ohm's law in this video. That will most likely be tomorrow. But the rules are basically, hey, conservation of charge. So let's make up a number. Let's say I have some amount of current, I don't know, 5 amps going into this junction. So that's the total current. If 2.5 goes this way, well, then conservation says 2.5 has to go this way. So it's just like water flowing in a river. If some of the water goes one path, the remainder of it has to go the other path. I definitely guessed on those currents though. You wouldn't want to do that. You would definitely want to do math, which I'll teach you about later. The other idea, the big rule with voltage that you guys will like, is called the loop rule. And the thing with the loop rule, which I won't draw on this and clutter it, is if I take a loop, I can actually make 2 loops in this circuit. So I can do an inside one that I just showed and then an outside one. Each loop, I only go across one resistor. So this one's kind of weird, but it then says whatever pressure the battery gave, 9 volts, in that loop, just that loop, this must lose all of that pressure. So that would actually lose 9 volts. The analogy for this one's not as easy as the current one, but it's like water coming down a mountain. It starts with potential energy, in that case, at the top of the mountain, and no matter what path it takes down the mountain, even if it takes 5 different paths, it's still going to lose the same amount of energy on each individual path. All right, so the analogy for that one's a little bit trickier, but it still is a good connection if you want to refer to that. So each of these, which again I know is weird because you guys will be like, what? How does each one lose 9? But in this loop, so this waterfall path down the mountain, it would lose 9 volts to get down, and this outside, this one would also lose 9 volts. So I'll get to those later when we get more heavy into the math, but this one, I really just want to talk about total resistance and total current and what happens to those when you create a parallel circuit and add multiple paths. So the math for this is not going to be just the sum of these resistors. This one is the tricky equation. This one is actually an inverse relationship, and the total resistance that it's equal to is even 1 over RT. So it's the sum of the inverse for how many resistors there are. All right, in this circuit, of course, I only have 2. So the total resistance, 1 over RT, is equal to 1 over 3 ohms plus 1 over 3 ohms. Good news is I chose identical resistances, so we don't have to do any lowest common denominator or anything. But this will then equal 2/3. Well, be careful with this because, yes, 1 over RT is equal to 2 over 3 ohms. That's not the total resistance because whatever we're solving for needs to be in the numerator, and look at where the units are. They're in the denominator. So real simple, what do you have to do with this? Just inverse it. All right, so if I flip it around, the total resistance is then equal to 1.5 ohms if you want to write in decimal form. Okay? The question then is, which is really weird, what happens to the total resistance and I guess the total current if I actually do add more resistors in parallel? So what if I add one more? So try not to take forever drawing this. You guys notice too, I'm not drawing light bulbs, I'm just drawing resistors, so I'm sure you saw that on the example problem. All right, and I won't label everything on this one, but what if these are all 3 ohms? All right, this is still 9 volts. What would be the total resistance for this? Well, it's again the inverse equation, but I have 3 this time. This one mathematically works out really nice for us. It ends up being 3 over 3 ohms. If I then take the reciprocal of that, the total resistance for this is 3 ohms over 3, which simplifies to 1 ohms. So this is really, really bizarre, but the total resistance, when you add more resistors in parallel, it actually goes down. All right? Think of it like, I heard from somebody I was working with recently, think of like a grocery store. So if you only have 2 lanes to go through, it's going to get backed up. All right? The people are going to be waiting. But if you open up another lane, then it's not going to get as backed up and more people will be able to get through. I like to think too of just more paths, more possibilities, more options for the current to choose from, so there's less resistance. So it still works with the water analogy with multiple path streams, but I like that shopping cart one that I heard as well. All right, you guys are going to have the concept builder to do for this one on equivalent resistance. That means total resistance as well, so don't get confused when you hear equivalent. It's going to be for both series and parallel, and just a heads up, I won't show it on this video, but you will get resistances that are different. So let's say this one instead was 2 ohms. You would actually have to do 1 over 3 plus 1 over 2 and get the lowest common denominator. So lowest common denominator for those would be 6, so it would end up being 2 over 6 for the 1/3 one, and 3 over 6 for the 1 over 2 ohms one. Okay, I might shoot out another video on that one if you guys are having trouble, or just give you an example problem. But the concept builder is your assignment for today. Go ahead and submit it in Canvas when you get it done, and give me any suggestions on these video guys. All right, good luck.